Hello world, my name is Eugene and welcome to my vlog. I call this vlog Code Review. This new video series focuses on software development. In this series, I will take you on a tour on the engineering of an intelligent system. Before we continue though, let's take a look at a demo. This is the base system in which we will go through the code as we extend its features. So, let's get started.
I'm casting my iPhone screen onto my MacBook, and the demo is on a chatbot. It is a Facebook Messenger chatbot. It's called Dr. Lee. And I'll talk a little bit more about the background of this chatbot. But basically, it tries to ask some simple math questions, specifically multiplication questions, just single digit. So let's start with hi. And he asked me, ready for the multiplication table challenge? I can say, yeah, sure, whatever. Sure. 20. 54. We'll see how fast I can do this. And because it takes a little time going round trip, so it is a little, it sort of limits my speed. But for someone like, in grade school, I think this is just perfect. And you'll see that you'll actually see a lot of zeros. Maybe out of so it'll ask me 20 questions, and we'll see like maybe 4 or 5 zeros, and it's because of statistics. I am generating the digits randomly, and so for each digit, there's a 10% probability that it is a 0, and when you have two numbers, that's 20%, and when you have 20 questions, you'll see something like maybe 4 or 5 questions with 0 in it. So this is probably something that that we can do some improvement. Okay. Let's see. And same thing goes to other numbers as well, right? But just that E0 is a lot more obvious. So one of the comments I was getting is that, there's a lot of zeros. Hey, I'm getting all the easy questions. Wrong? Yeah, I did that intentionally so that you can see what it looks like to give a wrong answer. Sure, you might not believe me, but anyways, so after 20 questions, it tells you that my score is 19 out of 20, and it took me 1 minute and 47 seconds to do 20 multiplication questions. What happened if I go high again? So we're going back, right? What if I say something else, like something nonsense? So yeah, so as you can see, this chatbot is still in a pretty early stage, and its natural language processing part is still not as mature. And in fact, that for something that it does not understand, it actually have a default message that gets pushed back. And here you can see this is actually my Facebook ID. So yeah, sort of a debug message that I was, to see whether I could actually get the Facebook ID, which I could. And let's see, hey, yeah. So we start over again, 21. And what happened if I go, hey? Yeah. Oh, bye. Hi. Yes. So one thing though you can see is that we've answered question 1 and we're on question 2. So if I go yes, you'll start from question 2. But yeah, so there's still a lot of room for improvement. And that's the purpose of this vlog series. I'll be walking through implementing additional features as well as improving the NLP of this chatbot. So here we have it. That's the demo.
Now you have seen the base system. Let me give you some background of the project. I started this project a few weeks ago when I was trying to help my son improve his speed in basic math. I started by making up 30 single-digit multiplication questions each day, but soon I found it was too much work, and for my son, he found it pretty boring. At the time, I was playing around with an NLP framework called Rasa. So I thought to myself, hey, why don't I build a chatbot and let it do the work? The result is the demo that you just saw. I found it to be quite effective as without realizing it, my son was doing hundreds of questions a day. In fact, he eventually crashed the bot a few days later. I will address this crash bug in future episodes, but for now, let's talk about what we're trying to achieve here. We will be building additional features on top of this chatbot. The NLP, as you saw, the current phase is still pretty simple. We like to make the chatbot smarter and able to interact with humans in a more natural and perhaps sophisticated manner. Also, I've promised my son and his friends to build a leaderboard so they can compete against one another. This is not live coding session in which I stumble through coding the system in front of you. Instead, I like to treat each vlog as a code review session. I'll pretend that you are on my dev team. Perhaps you are my manager who is responsible for delivering the product, or perhaps you are my dev lead who is responsible for making sure I deliver quality code. Or perhaps you are the new guy on the team who's trying to understand the system in order to pick up your own task on this project. I will pretend that we're running a weekly sprint. Each session, I will start with going through the tickets I was working on. I will do a short demo just like we did today, and then I will dive into the code showing the implementation. I used to work on a remote software development team, and we perform code review by sharing our screens, almost identical to a screencast like this. I hope these code review sessions are as realistic as they can get. One of the purposes I want to do this vlog is to hold myself accountable to have reasonable progress on the pet project. And in addition, I found code review to be a great place to improve coding skills for all participants. And yes, that includes you as well. I will be showing you my way of implementing the system, but it is by no means the best way. Your input and feedback are greatly appreciated. I hope you will participate by providing feedback to my code so that you will also feel like being part of the team. If you have questions, please don't hesitate to ask in the comment section or send me messages. This way, we all take away something valuable from this vlog series. For the first few episodes, I will pre-record the videos, but perhaps as I get more comfortable producing the vlogs, I will consider doing live code reviews in the future. For today's episode, rather than doing a code review, the purpose is to give you a background of the project. Today, the objective is to get you up to speed, not only on the system that we're trying to build, but also on the environment we will be working from. So, without further ado, let's dive in.
The technical focus of today's episode is my local dev environment. I'm running on a MacBook Pro on the OS X system. The project is built using Python 3.6. It is important to know that I'm using the Anaconda distribution of Python. I create a virtual environment using Conda, and all the required dependencies are installed within the virtual environment. Since this is supposed to be a code review rather than tutorial, I will not go through the details of setting up this environment here. However, I have included in the notes in a Google Doc the step-by-step instruction on how I set up my local dev environment. You will find a link to the doc as well as the source code repo below this video. Vital to this project is the database. I use PostgreSQL. I will explain more the reason behind this choice in future episodes. At the heart of this project is NLP, or Natural Language Processing. For this, I use a framework called Rasa. I'm really excited about Rasa. I used to work with other frameworks such as Google's Dialogflow, and for my work, I survey other cloud-based platforms, namely AWS Flex, Microsoft Luis, Facebook Wit, and IBM's Watson. These are all cloud-based frameworks in which you interact via a RESTful API. You don't see and you don't have control on what is behind the API. You can't decide on how you like to engineer the NLP. You simply get what they provide you with at their mercy. On top of that, you have to pay to use them. They do have some free quota, but for anything realistic, it comes at a price. Rasa, on the other hand, is open sourced and free. You get to poke around its internals to see how things are done, and in addition, you get to create a pipeline for doing the NLP. So, for example, you can decide how you like to tokenize based on the language you're processing. So for something like English, white spacing tokenization is probably enough, but for something like Chinese, you will need a different tokenizer. Rasa provides plenty of components for you to build your pipeline, but if there is something specific you need, you can always build your own unique component and plug into Rasa. In this series, I will not go into details of how Rasa works. I will provide you links to tutorials as well as Rasa Masterclass, which I think is the quickest way of learning Rasa. As we are talking about the Rasa pipeline, let's take a look at the code. On this screen, I have the code open in Visual Studio Code. This is the configuration file for Rasa. There are two sections, pipelines and policies. This reflects the two major subsystems of Rasa. The first is Rasa NLU. Rasa NLU is responsible for the processing of the messages coming from end users. We call the messages utterances. Rasa NLU is responsible for classifying the utterances into predefined intents as well as extract entities from the utterances. So, for example, in the utterance, I like to order coffee, this may be an order intent which we predefined, and we'll touch on that in a minute. And the coffee in this sentence will be the entity for this utterance. Now, that was the NLU subsystem. The other subsystem for Rasa is called Rasa Core. Once an utterance has been processed with its intent and entities identified, Rasa Core takes on the responsibility to predict the best actions in response to the utterances. One interesting fact, you can actually use Rasa NLU independent of Rasa Core if all you need is to analyze the utterances. And I find this useful in areas such as text mining. Okay, back to code. So you can see the top section of this config file is for Rasa NLU. So the part I'm highlighting here. We're using a pipeline called the supervised embeddings. Supervised embeddings is actually a pre-configured pipeline. Within it, there are components for how to tokenize the utterance, how to classify intents, how to extract entities, and even how to identify synonyms. We will go through the components in detail in future code reviews. Of course, we can write our own component if we wish, but I'm not sure if we'll get into that. Now, the second part, the part I'm highlighting now, it's the config for the policies. Policies are for Rasa Core to predict the next best action in response to the utterance. Here, we see two policies being applied. The memoization policy basically tries to match the best of its ability to the training samples we provide. We'll touch on that in a few minutes. The Keras policy uses LSTM, a type of recurrent neural network to make predictions. Okay, so that's the config file. Now, let's take a look at the training file for Rasa NLU. From nlu.md, you can see that everything with a double hashtag prepended is the user-defined intent. So for example, something like this, we have a double hashtag. The intent is called the reset intent, and we have the greet intent, and we have the goodbye intent. Those sentences with a dash in front of like these ones, They are the example for the intent. So let's say under the goodbye intent, it's quite obvious. The intent is called goodbye, and these are the examples, right? All right, so that's the training file for NLU. Let's look at the next file. The next file we'll take a quick look is story.md. Now, recall earlier when I talked about memoization policy where Rasa will try to match the conversation to the training samples. This file is where the training samples are. For example, under the multiplication table challenge, affirm, so here, if the user utterance begin with hello, which is classified as a greet intent, Rasa will perform the utter challenge action here. So if it identifies the greet intent, it will do the utter challenge. If the user says yes, like after so that's what when we saw in the demo. Yes, would you like to do the challenge? And if you answer yes, right, then the next action that it will attempt is called the action multiplication table challenge. Now, we will not worry about the other actions here for now. We'll talk about it when it's time, but we won't worry about it for now. But one of the major tasks of development of this chatbot is the implementation of this action multiplication table challenge and other associated actions as well. Right, so let's take a look at that. Action.py is where we implement the action multiplication table challenge action. So let me find it. There it is. The action multiplication table challenge, and it is defined in a class. And one thing very important that you have to do is define the name of the action here. We'll talk about that when we walk through the code. We're not going to walk through the detail of this file today, but I just want to show you where it is. And finally, let's take a look at the file that ties everything together, the domain.yaml. Let me scroll all the way to the top. So domain.yaml basically defines the universe of this chatbot. It defines what intent should this chatbot know about, what actions should this chatbot know about. We will go through this file in detail in later episode. One thing to note is that when I develop in my local environment, we do not use the Messenger app to communicate with chatbot. We communicate with the chatbot on the terminal. So let me do a quick demo on that. So on my editor, in the bottom, these are actually just normal terminals, right? They're like these ones, like these terminals. But I find it quite convenient that I can just type my comments here. So for the Rasa and the action server, they are actually separate servers, and that is why earlier I mentioned that on my my own server in the cloud that I am actually running them on separate containers. So s k-bash start action local. So now we're starting the action server, and this one is just Rasa shell. All right, so now we can start interacting with the chatbot. Hi, yes. Is that familiar? 0, 0. 30. Okay, we won't go through all 20 questions. All right, so I guess that's the walkthrough for the code for today.
Next week, we will take a look at our server environment. While the code is exactly the same, the running environment is quite different. It runs on Linux on Ubuntu 16.04, and it runs on 3 separate Docker containers, one for Rasa, one for the action server, and another one for the database server. For today's episode, you will find below a link to the code on GitHub. You will also find a link to a Google Doc that will point you to other important resources such as the Rasa Masterclass. Again, please feel free to drop me some feedbacks or questions. You can either leave comments below or fire me a message on Twitter. Thank you for watching. See you next week. Cheers!